Well, hi there. This is lessons 44 through 49, and lots of lessons to go through, but they shouldn't be too bad. So let's start with lesson 44. Lesson 44 is talking about roots. Okay, what are roots? Basically, what roots are is if you have a number like 25, okay, that can be broken up into 5 times 5. These are called roots. So you have a number that you can multiply something times itself. That's called a square root. Okay, so what we would say is the square root of 25 is just 5. In other words, what's that number you can multiply times itself? It's called a square because squares, when you're figuring out area, is length times width. And there's 2 of them. So it's called a square root, 2 of them. Okay, then there is, let's say you have a number like 27. That's equal to 3 times 3 times 3. Some numbers you can multiply times itself 3 times. If I were to ask what is the third root, 3 times 3 times 3, I would say third root of 27 is 3. And the reason they call it a third root is because there's 3 of them. Typically, people don't say third root, they say the cubed root. Because cubes are length times width times depth. And so there's 3 of them. 3 times 3 times 3, and you would say the volume of this is 27. So they call it the cube root if there's 3. The square root, put a little 2 up there. They don't normally put the 2, they just leave it blank because everybody knows that if nothing's there, that means it's squared. There's also things like the fourth root or the fifth root. And so we call those things fourth root, fifth root. We only give them weird number names like square and cubed for 2 and 3. Otherwise, the fourth root, the fifth root. And again, when somebody says, okay, for example, what is the fourth root of 81? What they're saying is what times what times what times what is 81. And they're fairly restrictive. I mean, this one happens to be 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. The third root of 27 is also 3. The square root of 9 is 3. So what you're saying is what times what gives you 9? Well, 3 does. What times what gives you 27? Well, 3 does. What times what gives you 81? Good news is it's not like something you have to figure out a whole lot because there aren't that many of them. And what will happen is you will end up getting used to them and you'll see patterns and you'll just go, okay, it's that. Because, I mean, think of it. There's not, let's say, for example, third roots. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is going to be 125. And that's pretty much what everybody knows. So there's only like 5 and you get used to it and you go, oh, third root of 64, that's 4. Or the third root of 125 is 5. You don't have to go, what do I do? And try all the numbers in the world. Nobody really talks about them. If they get, I want to know what's 116 times 116 times 116. Nobody memorizes that. They take their calculator and they figure it out. And you don't have to do that in your head. Primarily, you're just dealing with the simple ones. Same thing with the fourth roots. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is 256. And 5 times 5 times 5 times 5 is 625. That's the most anybody ever memorizes. If you were to ask somebody what is, 8 times 8 times 8 times 8, they're going to take a calculator. Nobody does that in their head. Nobody memorizes it. This is pretty much it. In the same way, you would say, okay, so get used to what's the fourth root of 16? Well, you just know that's 2. Or what's the fourth root of 625. Well, you know that's 5. It's not going to be 12. It's not going to be 42. It's numbers that are fairly limited, and that's what you'll see in a math book. Anything beyond that, you're using a calculator. So that's roots. Note, though, that 1 times 1 times 1. So any root. So, for example, the 16th root of 1 is 1. Because 1 times 1 times 1 times 1 times 1 times 1 times 1, 16 times is still 1. Okay? So these are roots. Remember, please excuse my dear Aunt Sally. Roots go here. So this is, some people learn this as please remember, my dear Aunt Sally. Roots and exponents are the same thing. Another way to write a root, just a little FYI. So for example, if I want to know what's the square root of 4, well, that means what times what is 4? Well, 2. Another way to write that is I would say 4 to the 1/2 power is 2. Square root can be written as a 1/2. A third root of 8, for example, we know is 2. A way to write that is 8 to the 1/3 is 2. That's why exponents and roots are the same, because a root is really just a fraction exponent. You won't have to deal with that anytime soon, but that's why they're there. All right, that's lesson 44. Let's move on to lesson 45. Lesson 44 is about roots. Lesson 45 is going to be about this thing that we call volume. So we just talked about cubes. It's easy enough to figure out the volume of a cube because you were doing length times width times height. It's basically that times that times that. Okay. Another way to look at, so volume equals length times width times height. But that's only if it's a cube. If it is another shape, let's say, for example, a box instead of a cube, and you're trying to find it, you can still do length times width times height. Any kind of box thing is just length times width times height. Another way to think of it, though, is if you think about what is length times width, well, that's this area right here. Or again, I'll look at it this way. I'll call this width, and I'll call this length. That's that area. So the area of the top, or the area of the bottom, and then this is the height. So instead of saying volume is length times width times height, I can say volume is the area of the top times the height. Okay, and that should make sense. It's the same formula, but instead of saying length times width, I'm just saying area of the top. Well, that comes into play if you have something like a object that looks, redraw this. If you have an object that, say, looks like this, let's say you've got here, 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 and here, and here, here, and here, and here. Now this case, it's not a cube. It's not a box. It's kind of a funky shaped wedge of cheese or something. But the volume is still the same. It's the area of the top times the height. So as long as it is what we call a regular shape, in other words, the area of the top, it's consistent, it's not a curve, it's not a triangle-y funnel type shape, but it's whatever the top is, it's the same as like if you had stacks of paper just stacked on top of each other and they were all the same shape, that works. And if you had that top look something like this, and I'll give you a number, for example, say 6 was 4 and 10. Question is, can you find the area of this top? That's this. So this is 6, that's 4, this is 10. And the answer is sure. We've been doing that before. And so I know 6 times 4 is 24. I know if this is 10, that means this is 6, and then that has to be 6, and 6 times 6 is 36, but it's half of that, so it's 18. 24 and 18 is 42. So the area equals the area of the top. And then if this thing was, let's say it was 6 feet tall, well, what's the area of the top? 42. What's the height? Times 6. And 6 times 40 is 240, so 252. That would be the area. And if this was in, say, centimeters, then this would be centimeters cubed. So the volume is always going to be whatever the unit is to the third power, because you've got a centimeter times a centimeter times a centimeter, length times width times height. Each one of those is a centimeter. Centimeter times centimeter times centimeter, we call that centimeters cubed. Or if it's inches, it's cubed inches. But that's how you do this one. This is lesson number 45. And it is, this is everything on here. Volume is equal to the area of the base, or the area of the top. You can say the area of the top, or you can say the area of the base. That's the bottom part. I think your book does area of the base. But it's the same thing, top and the base, because they all are the same shape. That's it, times the height, how tall it is. And that is the deal. If it is stacking like this, so that it's consistent shape all the way up, we call that a regular solid, right solid. So on regular right solids, that formula works. Regular means that it is consistent. Right means that this is a 90-degree angle, that it goes straight up. Okay, that's lesson 45. Now let's move on to lesson 46. Lesson 46 is about order of operations with fractions. So lesson 46 is dealing with, let's say you have this problem, 3 plus 2 divided by 5. Okay, do you remember order of operations? P-E-M-D-A-S. You do parentheses, no parentheses here. Exponents, none of those, or roots. Multiplication, none of those. Division, yeah. So you do this first. 2 divided by 5 is 2/5. And then you do addition. So you end up with 3 and 2/5 is your answer. Okay, that's what this becomes. You have to keep the order correct. Do in this order. Now, the only trick on lesson 46 is, okay, let's say you had this as a fraction. This can confuse you, but it really shouldn't. So you start mixing. What happens is people start mixing in their heads, oh, I have to get common denominators, or I have to do this or that. And think here, PEMDAS. Okay, I have something plus something divided by something. What do I do first? That. So pull that aside, and I have 3/2 divided by 5/2. Now, you know from fractions, we never divide fractions. We say 3/2 times 2/5. We flip this thing, and then we turn it into a multiplication. Then, well, I know 2 cancels 2, and I end up, this is 3/5. Okay, so I do this first, and I end up with 3/20 plus 3/5. Now I have an addition problem. Well, I need to have a common denominator on these, so I'm going to multiply top and bottom by 4, and now I have a common denominator. And so I have 3 plus 12 over 20, or 15/20, or I can reduce that to 3/4. And that's how you do it. So it's important that you don't just start getting common denominators or start canceling things because you see a bunch of fractions. You have to use all the rules you do one piece at a time. And that is lesson 46. So let me look at something a little different here. Let's look at practice problem B on lesson 46. And what that one is it gives you a bunch of stuff to do at once. 4 1/5 plus 2 1/3 times 5. Okay, so here's what you have to do. You have to think, what do? I don't know. Let's start with the simple stuff. We never do mixed numbers in algebra. We just don't. So we change this one to 21/5 plus 7/3 times 5. Again, 2 times 3 plus 1 is 7. 4 times 5 is 20. Plus 1 is 21. Okay, now I do my PEMDAS. Okay. No parentheses, no exponents. There is a multiplication. And remember, 7/3 times 5 is the same as 5 over 1. In multiplication of fractions, we just multiply the numerators, and I get 35/3. 7 times 5 is 35. 3 times 1 is 3. In multiplication, that's what we do, which is different than subtraction and addition. So 21/5. Now, I did my multiplication. There is no division. I have an addition problem, so that's what's next. In fractions, when I add them, they have to have a common denominator. So I'm going to multiply top and bottom times 3 and multiply top and bottom times 5. And I end up with 15 on the bottom. 3 times 21 is 63. And 35 times 5 is 3 times 5 is 150, 175. And then I just add those together. 175 plus 60 is 235, 238 over 15, and that's it, the answer. You can't reduce that. So that's it. But notice I start with this, and I have to think of a lot of things at the same time. That's where you're now taking your arithmetic skills that you learned in kindergarten through 6th grade, and you're saying, okay, I have to assume I just know those. And now I have to know how to do this. I have to know how to do that. And then I have to remember this. And then I have to know how to multiply fractions. And then I have to know how to add fractions. And then I need to know how to reduce fractions if I can. Again, remember 3 times 5 is 15. 3 doesn't go into that. 5 doesn't go into that. That's how I know that you can't reduce it. That's lesson number 46. So you'll have several problems over the next few weeks, especially this lesson, that focus on that. So let's move on to lesson 47. Okay, lesson 47. Going to be all about this exponent thing again. But it really is just kind of mixing in a little bit of algebra. So for example, you know that the third root of 64 is 4. How do you know that? Because something times something times something equals 64. And you know that 1 times 1 times 1 is too slow. 2 times 2 times 2, it's 4 times 2 is not good enough. 3 times 3 times 3, that's 9 times 3, it's 27. 4 times 4 times 4, that's 16 times, yep, that's it. I mean, if you don't know it, you just do this. So I know the fourth root of 64 is 4. Okay. What this lesson is say, well, what if I want to know the third root of n? And I say, if n is equal to 27, what would that be? So what you're doing is you're basically doing an algebra thing. You're saying, what the third root of some number, I'm going to call it n, what is it? Well, if n is 27, what's the third root of 27? Well, that's 3. Remember, 3 times 3 times 3 is 27. Okay. What if n equals 2? Well, is 8. Third root of 8 is 2. Okay. So all you're doing here is you're saying, you're getting for example, in your practice problems, you'll say, okay, what's 2 to the x? I don't know. I need to know what x is. Well, if x equals 4, what's 2 to the x? Well, that's 2 times 2 times 2 times 2 times 2, or 4 times 4, which is 16. Okay. That's all you're doing. That's lesson 47, believe it or not. It's no harder than that. It's just, they'll give you something like this, and they'll say, well, what if x was this? Then what's the answer? Okay. That's it. Hope you enjoyed that little lesson. Lesson 48 now. Lesson 48 is all about, you guessed it, fractional parts of a number. What? No. Do you remember blank is blank of blank, or blank of blank is blank? Okay, what? So back in the day, a few lessons ago, you were saying, okay, for example, 15 is what percentage of 100? I might ask you, well, 15 is 15% of 100. But this is an equation which is fairly common, where you'll see something is something of something. That's like this guy right up here. So how we did those is we would basically write this as a math equation. Whenever they use the word is, that means equals. And of means times. And you have what number or what percent. Well, we'll just use x. So 15 equals 100 times x. I can x times 100, but I normally put the x second. Well, to figure out x, I divide both sides by 100. And I end up with x equals 15 100ths, or 0.15. So, and if I want to know what percent that is, so 0.15 is 15%. Remember, percents, you just take the decimal, go 2 to the right. So x is 15% of 100. Another way to ask it is you could say something of something is something. So, but it's the same idea. That means times, that means equal. Okay, so what is unusual about lesson 48, you ask? Well, I'm glad you asked, because I will tell you. Lesson 48 is when they say blank of blank is blank. So this is a typical thing. What they're going to do is they're going to say this thing here, or this thing there here, is what we're going to typically say. And they'll say, what fraction of, let's say 100 is 15? What fraction of 100 is 15? So instead of just saying what percent or what, they're going to say the word fraction, which means your answer needs to be in a fraction, not a percent, not a decimal. So x of means times 100 equals 15, or divide both sides by 100, and I get x equals 1500. So what fraction of 100 is 15? 15 100ths. The answer. And that's all lesson 48 is you're using blank of blank is blank. You're changing it into a multiplication times something equals something. And the thing you're missing, you're just going to leave it as a fraction. I'll give you another example. 7/5 of what number is 3/8? Okay, this is practice problem B. Well, I don't know, I'm going to write it as a equation. 7/5 of means times what number? Again, blank of blank is blank. I'm going to use x. Is equal 3/8. So I just have to find x. And multiply both sides times 5/7. And I end up with 5's cancel, 7's cancel. So I end up with x on this side equals 15 over 56. 3 times 5 is 15, 8 times 7 is 56. So 7/5 of this number is 3/8. Again, just using blank of blank is blank. That's lesson 48. Last lesson, 49. Lesson 14.9 is, instead of volume, we're talking about surface area, going back to three-dimensional objects. So go back to the cube concept, or box concept. Surface area is basically, you're asking on here, if you were going to paint this, how much paint would you need? Well, you're not filling this box with paint. That would be volume. You're spraying the box with paint. Surface area is how much on the outside is there. Well, I'm going to have to spray this side. I'm going to have to spray this side. I'm going to have to spray the top. And then the other three sides, the back and the bottom and that side. So surface area is going to be basically the area of all sides. Pretty simple. That's all there is to it. Now, in this case, this would be the area of the front and the back. So I'll just say the front times 2, plus the area of the side times 2, plus the area of the bottom or the top times 2. That's of a regular box kind of thing. Well, how we do this if it's a little bit weird. So let's say, for example, you have an object that looks like this. A triangle. Okay, it's not quite the same. So we're talking about the surface area of these is, you're basically just, again, looking at it carefully, and you're saying, all right, I'm going to, if you can put it on its side, I'm going to call this the front, and over here, the back. So I'm going to have the area of the front times 2. Okay, if this was tilted on its end, like this, let's say, draw this on, tilted on its end. I'd call this the top and the bottom. I won't draw it. That's that, plus all this other side. Well, you could do kind of what I did there, but this is the cool part. I can do the perimeter of this, perimeter of the top times this distance. In this case, I'm going to call it the height. H-E-I-G-H-T times the height. Okay, let me give you an example of one of those and actually do it for you, and this will make sense. So the surface area, I'm going to use the letter SA, surface A, area, equals the area of the front or the area of the top times 2, plus the perimeter of the top times the height. All right, so let's say, for example, I had one like I just drew, like here. And I know this is 9 by 12, and this is 20 long. So, and I say, what's the surface area? Okay, it's going to be area of the front. That's this. 9 times 12 is 108, but it's half of that, so it's 54. That's the area of the top times 2, because it's that one plus that one. 54 times 2, again, 9 times 12, and that makes a triangle. Half of it, 9 times 12 would be a square. Half of that square would be a triangle. So plus the perimeter of the top, well, I know that, oh, I have to tell you, this piece here is 15. So the perimeter top is 9 plus 12 plus 15. 9 plus 12 is 21, plus 15 is 31, 36. That's the perimeter of the top times this, 20. So that's the surface area. So it's going to be 108 plus 36 times 2 is 72, so that'd be 720. And so it'd be 828. And whatever this is, if this was, let's say, meters, then it would be surface area is meters squared. So that's it. Perimeter of this piece times this. Normally we say area of the top times the height, or area of the front times the length, but it's the same basic idea. I think your book calls it, I don't know, what do they say? They say, yeah, they don't call it either one. It kind of depends on how it's tilted, whether they call it the front or they call it the top. And that's how you do surface area. And that is lesson 49. That is the lessons for the day, and you have a great day.